Alright, so here's example 1. The figure below shows an unbiased fortune wheel. The fortune wheel is spun at random. So as you can see here, although this is not to scale, we have 5 different regions, each marked with different letters. So the letters are written from A to C. Find the probability that the arrow stops at the region A, B, and E. So here's the arrow right here. So the probability that the arrow stops at the region A, let me just denote that as P of A, will be the number of ways that it could stop at A over the total number of ways, which will be the number of regions marked with A over the total number of regions. So it will be 2 over 5. You can see that very easily. Now for part B, it's very similar, except we only have one region marked with B, which is this one right here, over 5. Now for C, notice that there is no region marked with E from this diagram. So what we can conclude from here is that there is no way for the arrow to stop at E, or in other words, the probability is exactly equal to 0. Alright, so for part B, if the wheel is spun 10 times, find the expected number of times that the arrow will stop at the region C. Alright, so first let's just find the probability that the arrow stops at C. So you can mark that as P of C. That will be the number of marked regions marked with C. That will be 2 regions, which are these ones right there, over the total number of regions will be 5. So therefore, the expected frequency, I'll just abbreviate it with EF of C. That will be equal to, let's see, so the wheel spun 10 times and the probability is 2 over 5. So it will be the probability times 10. That will be 4. So that's our expected frequency. And that ends this example.